So this is the beginning of my project. I apologize for doing this in parts. I have a huge stuttering problem, so I just broke it down bit by bit so I don't stutter a lot. Thank you in advance. Hi everyone. Today we're talking about acetylcholinesterase and the changes that happens to it. Today we'll see how these changes affects the way our nerves work. So the normal function of acetylcholinesterase is to break down a neurotransmitter called acetylcholine. This helps regulate nerve signals transmissions by quickly removing acetylcholine from nerve synapses after it's been used. Essentially, acetylcholinesterase ensures that nerve signals are effectively turned off once they've done their job, preventing overstimulation of the nerve cells. Now let's talk about the change. Instead of being born with it, this change happens when a harmful toxin sticks to acetylcholinesterase. This makes it stop working right and leads to a mess up in how nerves talk to each other. As said earlier, acetylcholinesterase is like a hardworking helper in our nervous system. It's responsible for breaking down a chemical called acetylcholine, which helps nerves send messages to each other. By doing this job well, acetylcholinesterase ensures that nerve messages get through smoothly without any hiccups. So it's kind of like a traffic controller for nerve signals, making sure everything flows smoothly. Okay, so here are my models. I have sarin, H2O, and acetylcholine. So when it's not functioning properly, the sarin is going to bond to the hydrolysis site where this would usually bond at. So what should happen would be this would bond to the anionic site, and this would bond to the hydrolysis site. But since sarin is already over there, it isn't going to bond properly. Here's the other part of my model. The green represents the beta pleated sheets, and the blue represents the alpha helix, and the black is literally just tying it together. This doesn't mean anything. So because of this change that I showed earlier in the 3D model, acetylcholinesterase can't do its job properly. Instead of breaking down acetylcholine, it lets it build up, causing problems with how the nerves send messages to each other. But it isn't a one-to-one perfect model, so there are some missteps in between. But yeah, honestly, that's the deal with acetylcholinesterase and its change. Understanding this helps us see how important protein shape is for how our bodies work. Thanks for learning with me today.